Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about how to find the derivative of logarithmic functions, specifically the tough ones, where we need to use our properties of expanding logarithms in order to solve them. So in other words, I'm talking about problems like this. If you need to take the derivative of the natural log of, in the numerator, quantity 3x plus 3 times x minus 1 to the fourth, all divided by the square root of x plus 2, then we can find this derivative. But before we take the derivative, we actually have to expand it using our properties of logarithms, which we learned from pre-calc. So then real quick, going over those three properties again, we have the multiplication property, which says that if you have the natural log of x times y, where x and y can be anything, then you can break this up and write it as the natural log of x plus the natural log of y. The parentheses are optional here, you don't need them, but I think you see the bigger picture is I just turned one logarithm into two. And the advantage of doing this is a minute ago I would have needed the product rule here if I wanted to take the derivative, but now it's two very easy derivatives with the natural log of x and the natural log of y, and I'm going to be reminding us how to take these derivatives in a minute. So that's the multiplication property. The division property looks very similar, except if I have natural log of x divided by y, then this is going to equal the natural log of x minus the natural log of y. And remember, what we're doing here is just rewriting it. We are not taking the derivative yet. We still have to do that in the next step. And then finally, the last property, maybe you don't remember this one, this is the power property. So for instance, if I have the natural log of x cubed, I can rewrite this, and again, this is not a derivative, although it's going to look like the power rule. I'm going to rewrite it as 3 times the natural log of just x. In other words, you can move your exponent out in front. You can only do that if the whole thing is raised to the same power. So for instance, if I had the natural log of x cubed plus 3, then I cannot pull this 3 out in front because the 3 is not raised to that power. However, if let's say I had natural log of x plus 3 cubed, okay, now I can pull this 3 out in front because everything's raised to the third power, and I can write it like this, and this is very nice. And one final reminder, the derivative of logarithmic functions in general, which I covered in a different video, if I have the natural log of x, then the derivative is just going to be 1 over x. That's the easy one. And then more broadly speaking, if I have natural log of, let's say, 5x plus x cubed, again, this is not a product rule, so I wouldn't rewrite this at all. And if I tried to, like let's say I try and rewrite it like this, natural log of 5x plus natural log of x cubed, this would be horribly wrong because it's not multiplication, it's addition, so you can't do this. But don't worry, the derivative for this is very easy. You just put the derivative up top. In other words, 5 plus 3x squared is the derivative of the thing in the parentheses, and then in the denominator just goes my original 5x plus x cubed. And in case you're curious, this does not simplify, and so this would be my final answer. So with all of that being said, now let's look at some practice problems where we are going to use our properties of logarithms in order to solve them. So the first one I have here is the problem I left off in the last video. Y equals the natural log of 3x minus 4 in the numerator, and in the denominator, x squared plus 1. So the first thing I'm doing before I even take the derivative, I notice I have division here, which means I can just write it as subtraction. It is going to be y equals the natural log of 3x minus 4 minus the natural log of x squared plus 1. And now I just take two derivatives. Going to be very easy for me. The derivative of the natural log of 3x minus 4 is numerator, the derivative, which is 3. And then in the denominator is my original 3x minus 4. No, those 3's do not cancel. And now minus the derivative of natural log of x squared plus 1, fraction bar, and the numerator is 2x. And then in the denominator is x squared plus 1. And if you're having trouble with how I'm getting these derivatives, especially so quickly, then I'd recommend you watch my previous video, which explains how to do these easier ones. And then you can come back to this video, and you'll find that these are a lot easier than we think. So that's it for the first one. We're done. And no, that second term, 2x over x squared plus 1, that does not reduce, because there's no x where the plus 1 is. So yeah, this is it. Okay, we're just going to look at a couple more now. Number 2, I have f of x equals natural log of big fraction bar of x to the 4th times 2x plus 3. And in the denominator, I have x to the 11th plus 12. So let's see if you can take this derivative on your own this time. I have a feeling you might have trouble with the numerator, but that's okay. When you think you have it, unpause the video and I'll show you the solution. Okay, so the first thing I'm going to do is not taking the derivative, it's just rewriting it. The thing that some of you may miss, I'm going to break this up into 3 natural logs. The first is the natural log of x to the 4th, and then since there's multiplication here, right, x to the 4th times 2x plus 3, that means I'm going to write plus natural log of 2x plus 3. Not only is this allowed, this is what I wanted you to do, and if instead you distributed the x to the 4th, that's fine, you can definitely do that. Your numerator would just be natural log of 2x to the 5th plus 3x to the 4th. And if you did it this way, that's absolutely fine. I'm not going to do it this way, just so you know. But there's nothing wrong with it, so don't feel bad if you did it that way. And then of course, to finish off this line, I do have to subtract the denominator. It is going to be minus natural log of x to the 11th plus 12. And now I'm going to show you one more optional step before we take the derivative. I say optional because you don't have to do this, but if you spot it, then you're a genius and you're going to have an easier time for the derivative. And that is spotting the 4th power right here. Since x is to the 4th power, we can pull that out in front, and now you have 4 natural log of x, which is going to make your derivative just a little bit easier. And then we have plus natural log of 2x plus 3, and then minus natural log of x to the 11th plus 12. Do not get carried away here. This 11 cannot go out in front because the 12 is not raised to the 11th power. So in other words, we just have this, and now we're ready to take the derivative, which is going to be fairly simple. F prime of x equals, the 4 is a coefficient, just goes out in front and comes along for the ride. Derivative of natural log of x is 1 over x. If you want to write this as 4 over x instead, you can. I'll be doing that in the next step when I simplify. Next derivative, natural log of 2x plus 3. Derivative of 2x plus 3 is just 2. And then divided by the original 2x plus 3. And then minus derivative of x to the 11th plus 12. That's going to be 11x to the 10th power divided by x to the 11th plus 12. And like I said a minute ago, I am just going to write this as 4 over x because it looks nicer. But I'm going to keep everything else the same. And this will be our final answer. In case you're curious, what would you get if you combined the x to the 4th times 2x plus 3, and now you have a slightly different natural log? You would have this instead. Well, let me show you what you'd get. First, before I take the derivative, I would still split this up into 2 logarithms by doing subtraction like this. And then when it's time to take the derivative, I would say numerator is going to be, derivative of this is 2 times 5, 10x to the 4th plus 3 times 4, 12x cubed, divided by 2x to the 5th plus 3x to the 4th, and then minus, it is 11x to the 10th divided by x to the 11th plus 12. And in case you're curious, we can simplify the first one because all of these things have an x cubed in common. In other words, I can cancel out an x cubed, leaving me with 10x plus 12 in the numerator, and in the denominator, 2x squared plus 3x. And then the second term just stays the same. But regardless, if you missed that, it's not a big deal. If you have either this answer that I have on my screen or the one that I circled earlier, this one, then I'm going to be happy with you. If it's multiple choice, obviously you won't see both. You're only going to see one. In my opinion, this is the better answer because it uses more properties of logarithms like we were talking about. But if you get this version here, that's okay too. Especially if it's a free response sort of test instead of multiple choice. Okay, that's it for that one. Now just one more example today. This will obviously be the hardest one, but that's okay. I have in the numerator the square root of 2x plus 2, and in the denominator I have 2x plus 1 times the quantity x minus 3, and the whole x minus 3 is to the 5th power. And when you're solving this, I want you to simplify it as much as you can using our properties of logarithms. And one more hint to you, because you might miss this, or you don't know what to do with the square root. Remember that square root of anything is the same thing as the 1/2 power. Just think about that when you're doing this. So go ahead, pause the video, try it on your own, and when you're ready to see the solution, unpause the video. Okay, so as far as the simplifying goes, I would break it up into 2 steps. First thing I would do is write this as natural log of 2x plus 2 to the 1/2 power, because that's what we do with square roots. And then minus the natural log of 2x plus 1. And maybe you're wondering what to do with that last one. Should it be plus? Should it be minus? I will tell you, it should be minus, because it's still in the denominator, and denominator always gets minus. So minus quantity x minus 3 to the 5th power. That's the first simplification step. The second simplification step is where we pull those exponents out in front. This is super crucial that you do this, because if you miss it, then you're going to have a very tough time taking the derivative of these things. So just put the 1/2 out in front. The second term shouldn't change at all. And then for the last one, we pull the 5 out in front, and we get this. And now I'm ready to take the derivative. Just remember what to do with that 1/2 and the 5. They are coefficients. They just go out in front and come along for the ride. So g prime of x, the derivative, is going to be 1/2 times derivative of 2x plus 2 is just 2. The denominator will be 2x plus 2. I will simplify this in the next step. Don't worry. Now minus derivative of natural log of 2x plus 1. That's going to be numerator 2 divided by 2x plus 1. And then finally for the last one, it's going to be minus 5. And then the derivative of natural log of x minus 3 is 1 over x minus 3, because the derivative of x minus 3 is just 1. And then in terms of simplifying, I would just make it easy. I would say this 2 cancels with that 2, because it does. So the first term just ends up being 1 over 2x plus 2. For the second term, nothing cancels, because the plus 1 ruins it for us in the denominator. And then for the last term, I'm just going to put that 5 in the numerator, because that's allowed and it looks nice. And this is going to be our final answer. And if you got anything different, it's probably wrong, or in the very least, it's not how I would have liked you to solve it. So that's going to do it for this video. If you have any questions, please post them in the comments. Have a great rest of your day, and I will see you in the next video. Take care, and bye-bye.